All right, so good afternoon, good morning, good evening, and welcome. So today we're going to be having, this is part 2 of our review in relation to our semester 1 final. The first part was all about desmos, and the second part is going to be more ingrained of trying to figure out if you see other things that you'll encounter on the test that you won't be able to put into desmos. So how can you solve them? As we discussed in class, 60% of the test you can put in desmos. The other 40% you can't. So if you want to get a good grade on this, you need to understand these concepts as we move forward and learn how to troubleshoot the problems that you see. Okay, we'll do a better job of that in semester 2 as well, but let's get started. So very first thing up on the board, off the bat, is what I was trying to get out of my mouth, is that we run into a problem right here. Okay, the first thing you want to notice when you see this problem is it's talking about the size of a tank in gallons versus how much was mowed per gallon. So for me, the analogy I use in car is about how much gas you put in your car versus how much mileage you can get per gallon, okay? So if you do that, you guys would know you could multiply these two numbers together, and that's how you would come up with a sequence, okay? Because this is how big a tank of gas that you have, a tank full of gas, and then for this tank, you can mow this many acres per these gallons. So if you multiply these two numbers, you'll get your answer. So this is 0.9, you put it in a calculator, this is 1.088, and this one's 1.125. So the answer to this is which mower mows more grass would be mower 3. All right, the second one, same setup. Selection of lawnmowers is listed below. Which mower would mow the most grass on one tank of gas? So this is the size of your tank. The tanks are a lot closer in size, but the amount they mow is different in size. So if you multiply this out, whoops, sorry, I put the wrong symbol there. You multiply this out together, it's been a long day. When you put these out, it'd be 0.756. This is going to be 0.884, and then this last one is 0.868. So, by looking at these numbers, which 3 is bigger? Well, it's mower 2. Simple setup. All right, car 3. We're talking about fuel efficiency. Which one is most fuel efficient? In order to get that, ladies and gentlemen, what do you have to look for? Well, you got to look for how many miles, or in this case, kilometers, do they get on a liter of gas, okay? So here, this car 2, so we know car 2 gets 13 kilometers, okay, per 1 liter. But what does car 1 get? Well, we don't know, not car 1, just like that. You set it up, ladies and gentlemen, we know we get uses 7 liters of gas per 90, so you actually need to divide this, okay? Do the math, 1, 7, carry it out, you guys get the drift, and you'd end up with 12.857, okay? So then the question becomes, which car is more fuel efficient? Because that's what it wants you to find, and that would be car 2. So this car is more fuel efficient, and how far can it go on 4 liters of gas? It can go 52 kilometers, okay? Same setup with car 4. All right, 9 liters of gas, so we go 9 divided by 110. So car 1, in this case, is going to be 12.22 when you put it in the calculator. And then car 2 is going to be 11 kilometers. And so how far, which one's more fuel efficient? Well, it's car 1. And if you have 2 liters of gas, times that by 2, 24.4. That's how far you can go. Okay, simple math, but what I need to make sure you guys is understand the concepts behind it. It's getting there that's the problem. Number 5, conversions. Okay, we really didn't do too many unit conversions. Some of you guys practiced it in biology this year. So with us, it's trying to figure out what we're doing. So we're going from miles per hour to feet per minute. So, and then they give you a scale. 1 mile is to fit 5,280 feet. So we need to take this. First, we're going to change this miles. We're going to change it to feet. And how do you do that? Take your conversion chart and you multiply it by 45. Okay, when you do that, you end up getting 2,37600. Now, what is this? This is feet per hour. Okay, now, do we want to know how many feet per hour we're moving? No, we want to know how many feet per minute. So we need to take the hour now and reduce it down to minutes. And how do you go from 1 hour to 60 minutes? You divide something by 60. Okay, so you would take your original number, 237,600, you put it in the calculator, divide it by 60, and you would end up having 3,960 feet per minute, which is what we're looking for. Same philosophy goes for 6, world-class cyclist. He or she is going to go 25 miles an hour. I use this off of Tour de France for Lance Armstrong. The fastest he ever averaged was 26. So 25 is relatively on average for a world-class cyclist. So when you set this up, multiply it out with a calculator, you get 1, 3, 2, and a bunch of zeros. Okay? Then how you set this up? Take this number then, and remember this is feet per hour, and we need to go per minute. So when you divide it by 60, because there's 60 minutes in an hour, you'd end up with 2200 feet per minute. Simple setup. Last but certainly not least, on the first page only, okay? Mr. Parsons is not a world-class cyclist. Sorry, Mr. Parsons. He knows that though, unless it's played on Nintendo Switch, which he's very good at. When he starts to ride his bike in real life at 8 a.m. one morning, he makes an effort to bike 10 miles. At 8:30, he is still 7 miles from his destination. What is his average rate of change? Please label in miles per hour. So the question then becomes, if you start at 10 and you're 7 miles from your destination, how far have you traveled? Well, he's traveled 3 miles. Okay, and then how far did it take him? It took him, or how long? It took him 30 minutes. So if you want to convert this, it's pretty simple, right? Multiply 30 by 2, you get 60 minutes, which is an hour. So in that case, you take 33 miles, you multiply it by 2, you get 6 miles per hour. That's his rate. All right, simple setup. Make sure you guys know the conversion and understand the process of going from a 10 to 7, meaning he's went in 3 miles in 30 minutes. Okay, so if the equation was set up a little differently, say going if you're 4 miles out from something, 30 minutes later you're a mile in, how fast would you be going? You're going 2 miles an hour. Okay, because if it takes you 30 minutes to go a mile, then it's going to take you 60 minutes to go 2 miles. Hopefully you guys get that gist. Okay, number 8. This was one of the trickiest ones in relation to how we actually needed to solve this, okay? I got my answer sheet over here because I wrote it out. Big thing with this, carnival worker sells cotton candy. At some point in the day, they raised the price by 25 cents. That's a big indicator for us, okay? So we're starting off with an original price, and then somewhere along the line, we raise it by 25 cents. After the price increased, the total dollar amount collected selling C, and this should say cotton candies, not bottles. New price is given by the following equation. So we have a new equation after we raise the price. So the question then becomes is, what is the original price? Well, if we know this is the new price, and they raised it by 25 cents, then you simply subtract to get $1.50. So we know the original price is $1.50. The question then becomes is, what does this 12 represent? Well, remember on y equals mx plus b, okay, the b is the y-intercept. So we know we're starting at 12. So for some reason, he sells stuff throughout the day, but then they raise the price when they hit 12. And what does 12 represent? Well, 12 actually represents your initial starting point of your new price. So your initial starting point of your new price is what? $12. So on the graph, okay, they don't start down here at 0. They start up here at 12, and then they shoot forward. So that means it's $12. So how would you write this down as a problem? This is your formula. So then the question becomes what? How can you solve this equation of 150C equals 12? Divide both sides by 150, $1.50. And then when you do that, ladies and gentlemen, C equals 8 cotton candies. Okay, hopefully you guys all see that setup and how that works. Okay, that we're going from, here's your new price minus your increase to get your original. And then we need to know that we started at 12. There should be a little dollar sign up here. So I'm using green for the dollar sign. So they started at $12, but really they had to get up to 12 by selling the initial quantity. And once they sold 8, they're like, all right, we're done selling 8. We're going to raise the price and sell more. That's supply and demand. You go from there. Solve the following equation for a given variable. What we're going to do, ladies and gentlemen, is solve for x. So we're shooting for an x equals. Solve for b. Shooting for b equals. So let's start with the b. All right, that seems a little easier. So if I'm going to go y equals mx plus b, how would I move the mx to the other side? Well, this is multiplication, but this is a little grouping. And how do you move something if you're adding it? You would subtract it from both sides, okay? So you subtract mx minus mx. And so, ladies and gentlemen, you have b, and then you have y minus mx. So what is your equation? It's b equals y minus mx. Remember how to do that, okay? Pretty simple, straightforward, but we go from there. Next, on this one over here, use a darker green, weirder color. All right, y equals mx plus b. Once again, now we're going to solve for x. So we're going to move everything around. So first thing is, subtract the b from both sides. Okay, when you subtract the b, you get y minus b equals mx, right? And now you got to solve, you got to isolate the m, or you got to isolate the x, and this is multiplication by doing the opposite of multiplication, which is division. So in this case, my x is now by itself because they cancel out, and my answer is this. All right, if you have any questions about that, come see me in class. But that's kind of the same setup. So this is the same way. We're going for a equals, and then we're going to go for b equals. Okay? So start with a. 12a plus 6b equals c. So we're not going to touch the a. So the first step then, subtract both sides by 6b. And when you do that, you get 12a on this side, and then you have c minus 6b on this side. Now, ladies and gentlemen, this is multiplication, so you need to do what? Divide by 12. Okay? So when you get to this point, then you need to realize, okay, let me do simplification. And when you simplify, these cross off, so you got a equals. So we're at that point where the 12, no, needs to be reduced. Remember, this is actually, you can split this. So it's going to be c over 12 minus, and what is 6 divided by 12? Well, it's actually a fraction of 1/2. Now, there are multiple ways of writing it. You could see it as a equals 1 over 12c minus 1/2 b, or you could put the c on top and the b on top, but just remember the concepts behind both of them, okay? And then solve for b here. So if I solve for b here, I'll just use the equation now. We're going to subtract 12a from both sides. All right, and then when you do that, you get 6b equals c minus 12a. Next step, divide by 6. Most of you know how to do this. Sorry, I get a little crazy with my 6's. Ends up with b equals. And then it's going to be c over 6, right? Or it'd be c and 1/6 minus 2a. Okay, because 12 divided by 6 is 2. There's your set. All right, number 11. A line has a slope of 2, which equations intersected at exactly 1 point. Well, remember what we had talked about. A slope is y equals mx plus b. M represents what? The slope. So it's y equals 2x plus b, right? The equation then goes on to say, as we talk about it, would be knowing that how do you create parallel lines? Well, parallel lines have something in common, right? They have the same slope. So if they have the same slope, they're never going to cross. So you want to get a number that's different from the same slope. It doesn't have to be a negative number. Okay, it could be a positive 3. Will they eventually cross? Sure, they'll cross at one point. But in this case, they all are the same. So negative 2 is not the same as 2. So that's 1. 2 and 2 is a no. 2 and 2 is no. That's a yes. So we got 2 there. All right, Mr. Trubisky throws a football. 8 feet in the air. The wall, oh, dang it. That should be the ball. I had a nice student point out I had 2 spelling errors, and I found the second one. The ball was in the air for a time t, 5 seconds. What would be the reasonable domain and range of the situation? Please display it as an inequality. So what I want you guys to remember is, what is domain? Okay, remember what domain is. Domain is the x values. Remember we had dx, and range is the y, so it's dx and ry. So if I were to be a gentleman here, here's my little stick figure gentleman, okay, and I had a football and I threw it. And I threw it to my buddy standing way over here, okay? What kind of line is represented on that? Well, I threw a little arch. What you guys need to understand is if I connected my buddy and me in a straight line like this, and then I drew a line like that, what is this? Well, technically, this is a graph, okay? We're graphing it, all right? If you guys can't see that, let me delete this, or erase it, and let me draw my beautiful stick figures again, okay? But this time I'll draw it a little differently. So we have our graph sitting just like that, okay? And what we're going to do with our graph is, fix my lines here. So we have our beautiful graph. And what I'm doing is I am sitting on the left-hand side, the negative column, and I'm over here, hanging out on the ground, saying, what's up? Here we go. And I take the ball, and instead of maybe a football, like Mitchell did, we had a soccer ball on the ground, or if I was a kicker, but that part doesn't really matter. But what you're doing is you're taking the ball and you're throwing it to your buddy on a nice little arch over to here, okay? So when I draw the line like that, hopefully you guys can see what? That it's a nice little arc, okay? It's a quadratic that we haven't really dealt with yet. But can you represent a reasonable domain and range for this inequality? Yes, you can. So what it means is that for me, if I'm going at 0 seconds, if I'm going at 0, then what I need to do is understand is that I am sitting right here, and I'm starting at 0, and I am going to throw the ball. Okay? I'm going to throw it from here, and it's going to land here. And how long did it take me? It takes 5 seconds. So from here to here, it's 5 seconds. So ladies and gentlemen, left to right is the what? Is the domain. So that's the domain. Starting from 0 to 5 seconds. Now the question though is, what is the range? How high did I throw the ball up? It doesn't matter. We don't know. So a reasonable domain for this would be h is greater than or equal to 0. Okay, because the height of the ball, we don't know how high I threw it. When we get to quadratics in this summertime or in the springtime, right after spring break, we're gonna cover quadratics in like February, but we're gonna do an activity. It's an Angry Birds project where we will throw a ball like this. Okay, we'll have it create an arch. We will throw it. Some of you will throw it from like 2 feet off the ground. So you would start at 2 as your x, or yeah, you start at 2 as your range. And when you throw it, we'll measure it 30 feet to throw a ball into an area. So all of you will have a similar starting point, and you'll have a similar end point. But it's your arch of how high you throw the ball where everybody will be different. And that's what makes it unique. And so that's what this is about too, okay? So the domain is this, and here is your range. Just remember on a function like that of how you would interpret that, okay? Next, What is the best way to clear the fractions in the following equation? Well, in order to clear a fraction in this equation right here would be to do what? If I want to get rid of this fraction, I got to multiply it by the common denominator. And so the common denominator with this would be what? 6. And that's the answer. If you multiply it by 6, you would simplify this, right? So that would be 2y minus 3x equals 24. Do I want you to do that? Nope. I want you to tell me how would you get rid of the fractions. Multiply it by the common denominator. All right, the function below is used to model the average salary earned by school employees T years after being hired. What does the number 40,000 represent in this equation? That is going to be your initial amount. Okay, this is your initial amount. And then what does the number 15,000 represent? That represents oh wait, sorry, I'm writing that wrong. 1,500 represents, ladies and gentlemen, your yearly increase. So if you were to ask to write in, sorry, brain is starting to shut down. Increase. If you guys know that I start at this, every year I work, I get this dollar amount. So if I worked 5 years, I would replace this T with a 5, multiply this, and then add it into that, and then you get your yearly salary. Last page. The function below is used to model the number of donuts left n minutes after the opening of a store. So what does the 200 represent? It represents the beginning, how do I count? Count of donuts. Okay, that's how I represent this. And then what does the number -4 represent? This represents the number of donuts. And I do want you to write it down like this. You lose every what? Every minute. Because it said up here that n is the number of donuts left n minutes after opening. So it would be the number of donuts you lose every minute. Make sure you know what it represents in terms of that connotation. It's not every hour, not every day. In this case, it's every minute. Okay? 16. What is the domain and range of the function of the graph shown below? Remember, domain is the x values. Okay? So on here, when it's talking about a function, we have our first x value at 3.5. So it's d equals 3.5. It also equals the x value here of -1. It also equals 2, and it also equals 3. And then the range is the y values. And this you only represent one time if it's duplicated. So for example, vertically speaking, as we go down, our first range is at 2. Okay, because we know going down that these two dots are the same thing, but it's the same range. And then my next one is a 1. And my last one is a -1. So which one of these actually connotate towards that? Now I wrote it backwards here, but it's still the same thing. And that would be A. Okay? Remember the difference between domain and range. Okay? Domain and range. Simple setups like that. 17. While running through his neighborhood, I noticed that 4 of my strides covered 3 squares. As a curious individual, I decided to measure each square. And I noticed that each one is about 4 or 5 1/3 foot long. What is a reasonable estimation for my stride? Okay, so if I know I have 4 strides from here to here, and that my equation setup is 5 1/3, I know my total distance would be, if I have 3 squares, multiply this together, it actually equals 16 feet. Okay, so I'm going 16 feet. Now, how many strides do I have? 1, 2, 3, 4, 16. Let me rewrite that. So 16 divided by 4, each one of my strides is 4 feet. That's if I'm running, not if I'm walking. So as we go from there, there's your answer to that one. And then last but certainly not least, number 18. It's not 19, so that's the third typo. Which method represents the correct way to solve an equation? They're all set up the same. It's the next step that counts. First step is PEMDAS, parentheses, exponents. We can't do anything in the parentheses, so we need to distribute. So you take this 2 and you distribute here to here. The good news is this equation is right. 2x, and then 2 times 5 is 10. 2x. Nope, that's not right. 2x is correct, but then they forgot to distribute to the back end. That's not right. It should be 10. And then this one, I don't know what they're doing. They subtracted the 4 over, but same thing. 2x, and then this should be 10. We're missing the 10. That's not right. So the only answer is A. So ladies and gentlemen, if you ever have any more questions about this, please let me know. But that's it for this review, okay? I won't really have anything else for you. The only other thing I have as a reminder to you is that online through Galileo is the review that I will post, okay, that you can do over the weekend. And remember how to get into that is you go to the husd.org website, scroll down, go to math curriculum. You can go in through that way, through clever.com, okay? Or you can log in as your student, click on Galileo, and remember your login that way. If you go in through the math, if you go in through the portal, the math portal, and go through clever.com, the Galileo icon pops up. So it might be easier for you guys just to click on that because you log in using your school ID. The other Galileo portal, if you go through the student account, remember is your first initial, last initial. So my name is Jason Steiger. It'd be JS, and then your 5-digit ID, and then your password is the same as your always is. If you guys have any problems or questions about that, please send me an email or shoot me a remind message. Other than that, ladies and gentlemen, good luck, get some rest, and I will see you on Monday.